students, let's continue with the contention based protocols with reservation mechanisms in the synchronous protocols. So far we have seen about DPRMA, CATA and HRMA. Now let's see about these two, SRM, APA, FPRT. So these two are also the synchronous protocols. So in this video I want to explain about the contention based protocols with reservation mechanisms of synchronous protocols. So now let's see about the SRMAPA. What it means. SRMAPA is a soft reservation multiple access with priority assignment. This is a soft reservation multiple access with priority assignment. It developed with the main objective of supporting integrated service of real-time and non-real-time applications in ad hoc networks. At the same time, it maximizes statistical multiplexing gain. So the main use of this protocol is it's supporting both real-time and non-real-time applications in ad hoc networks. And also it maximizes the statistical multiplexing gains. Here the nodes uses a collision avoidance handshake mechanisms. So whatever the nodes that are present for communication, so those nodes uses a collision avoidance handshake mechanisms and a soft reservation mechanism. So that's why we call it as a soft reservation multiple access with priority assignment. So here the collision avoidance can be avoided by using the handshake mechanisms and a soft reservation mechanism. Okay, now let's see the next protocol, that is the FPRP, which is a synchronous protocol. FPRP is a 5-phase reservation protocol. So by seeing this term, what you understand, you are going to learn about the 5 phases in this reservation protocol. Okay, so now let's see. FPRP is a contention based protocol with reservation mechanism. So we are talking about the second level, that is the reservation mechanisms. So in that we are discussing about the synchronous protocols, not the asynchronous, only the synchronous protocols. So the last one is 5-phase reservation protocols, is a single channel TDMA, time division multiple access based broadcast scheduling protocol. So this FPRP needs global time synchronization. Just remember, it needs global time synchronization, fully distributed and scalable, reservation process in localization, and it involves only 2 hope neighbors, no hidden terminal problem. So these are all the features of these 5-phase reservation protocols. No needs of a global time synchronization is needed, fully distributed and scalable technique is needed, reservation process is localized, and no hidden terminal problems are there. So here the time is divided into frames. We are using it is a time division multiple access protocol. It's a single channel time division MA. So here the time is divided into frames. One is reservation frame and another is the information frame. Time is divided into 2 frames, reservation frame and information frame. Now let's see what is that. So this is a frame structure in FPRP. So I said the complete frame, this is a complete frame size, so whatever the frame length is, the complete frame is divided into 2 frames, that is a reservation frame and information frame. RF is a reservation, IF is a information. Okay, so here again the reservation frame is having RS1, RS2 up to RSN, N slots will be there. In information frame also you are having the N slots. Okay, so let's see here. Here each RF has N reservation slots. Here each RF, okay, that is the reservation frame is having the N reservation slots. N RS is reservation slots. Okay, so here each RS, again each RS is composed of M reservation cycles are there. So here M reservation cycles. So each RF is divided into N reservation slots. Again each slot, whatever the slot you are taken, each slot is divided into M reservation cycles. Again with each RC a 5-phase dialog takes place. So here the concept is raising, that is a 5-phase reservation protocol. So each reservation cycle is divided into 5-phase reservation dialogue. RR, CR, RC, RA, P by E. Okay. So now let's see what are these 5-phase reservation. Here you have to remember that the protocol, that is the reservation frame, is divided into reservation slots, and the reservation slot, each slot is divided into reservation cycles, and each cycle is having the 5-phase reservation dialogue. So here the concept is rising. So corresponding to IS, each node would be in. So whatever the IS here, it is there. Okay, so that IS, each node would be one of the 3 states, whether it is maybe transmit, receive, and the blocked. Okay, so that is the information frame, maybe the transmit, receive, and the blocked. Now let's see what that 5-phase protocol. So I said RR is there, CR, RC, RA. Okay, so now let's see this, and one more thing. First, RR, reservation request. It sends reservation packet to destination. Reservation packet to destination. First point. The second phase, a collision report. If a collision is detected, suppose any of the node, if a collision is detected by any node, that node broadcasts a CR packet. So whatever the node that detects the collision, that node is transmitting the collision report packet. Okay. The third phase, reservation confirmation. A source node, whatever the source node that wants to send the data, the source node, the contention will send a reservation confirmation packet to destination node. If it does not receive a CR message, that is a collision report message in the previous phase. Suppose the sender wants to send the data to the receiver. When it sends, whenever it receives, it does not receive the CR message. Whenever it does not receive CR, that is a collision report message, then it bindasly sends the reservation confirm by the sender. Next, reservation acknowledgement. Destination node acknowledgement reception of reservation confirm by sending back reservation acknowledgement message to the source. So here the receiver is sending the acknowledgement to the sender whenever it receives the RC, that is whenever the reservation is confirmed, then the receiver will send the acknowledgement. And the last one is the packing and elimination. So the last phase is the packing and elimination. So this is a 5-phase protocol. So packing and elimination. Use packing and elimination packets to transfer the data. So let's see, these are the different nodes. Here these nodes are participating in for data transmitting and the receiving. So the 1, 7 and the 9. Okay. So here whatever RR is nothing but reservation request. So here one is asking for reservation request, and here it is asking for reservation request. This node is asking the neighbor nodes for reservation request. Reservation request. Okay. After requesting, suppose this dotted is a collision report. So here it is one is sending the collision report. Okay. There is a collision is there. And this is the RA packet, reservation acknowledgement. So whenever the reservation request is sent, this 4 is sending the reservation acknowledgement. Reservation acknowledgement. And this is RC is a reservation confirmation. So whenever it receives a request and it sends a confirmation, it sends the confirmation. So this is way how the nodes are communicating by using this protocol. This is a 5-phase protocol. Okay. Thank you.